Welcome to another video on my Raspberry Pi 1B Plus, running Raspbian Linux and connected to network cable for VNC and of course internet right here. Serial cable for connection by laptop for serial terminal, necessary to easily control things. Of course, a Raspberry Pi camera, raspicam, which is live streaming not on the internet but to my screen, and a band cable to this project, which is about this chip, Max 522 digital to analog converter, controlled by SPI serial peripheral interface protocol, the 3-wire version, which means that master input, slave output and master output, slave input are combined, which also means that it is half duplex and not instead of this project, which is an analog to digital converter, full SPI, which is full duplex. A little bit different than usual is the presence of my Android tablet, which is also receiving the live stream of the raspicam. By the way, the stream has a few seconds delay. Not exactly sure why that is, but it's the way it is. So with the other camera I can have an easy switch. Then, what more can I say? The project is programmed in C and in Python. Apology, in Python, and I'm using the wiring Pi and PyGPIO. Anyway, things are now concentrating on the fact that the input is nice. It has the expected input, but the output is not always as nice as could be. So there are things to improve. And using the oscilloscope, to which the probes of course are connected, and I mean these 4 probes. So these are connected to the clock, then data and chip select, and this one is connected to the output or to the input of the chip, because last time I found out that although the first 3 probes show a nice signal, it doesn't always show on the chip. So I have to investigate that as well. Last time I also put some wiring changes, and that should enable to give more stable signaling, or signal catching, to put it that way. Anyway, so much for an introduction, and I was advised to do so. And let's go to screencast to see how things develop. Then on my screencast, as you can see, overload of windows, I'll reduce. So this is, let me name the tab, Minicom serial terminal, coming from indeed the Raspberry Pi Plus on top of the Raspberry Pi, to which the serial cable is connected, and it does start with a VNC connection, but I have to kill it because I want it like this. So this is desktop number 1. This is desktop number 2, which is running on the tablet, but right now not showing because I showed the video stream, and this one is enabling yet another desktop, which I might show or not on the Mac, for example, a MacBook. Right, then of course the Max 522 with streaming video, oscilloscope, which currently shows nothing because the program is not running, and I should make this one larger. Piscope, where this is showing the signals on the outside of the GPIO, this is showing on the inside of the GPIO on the board, which shows nothing yet because the program isn't running. And here I started, and this is where I start the video stream. Okay, now let's try. Oh wait, yes, and this is the original video stream. Well, what is original? One of the outings, and you can see here that this one is much brighter than this one. I discovered that last time as well, but one remarkable thing is that this window for some reason is much smaller. Last time it was much bigger. Why the change? I don't know, it just is. So last time I also changed the algorithm to publishing short numbers. The objective is still that I get to see rising sawtooth something like signal. Not happening. Why? I don't know, but this is now showing descending of those numbers, 255, 0, etc. So let me show much better. And now this is once again a problem, because here is nothing, and that happened last time as well, and I have no clue why. So I'm interrupting, starting again, and now suddenly I do get signals. What I also did was shorten the pause after sending a signal. And here you see the signals coming, and right now the probe is on the input, so that is normal. What is not normal is the time base, so I am shortening the time base on the oscilloscope. And that should show much nicer signal. And by changing each time base, and you can see here which time base that is. Let me play a little bit with Alright, if I change the focus, is that clearer? Alright, this is apparently as clear as it gets. But you see the signal. And right here I can see it even better than or with the bare eye. So there is some delay which enables it to be better. Another thing is that I don't see anything here, which is in itself strange. But since there is signal here and there is signal here, I am going to move the probe on the input to the output. So now you see that there is something strange. So why is the input not visible of the or the output to the LED not visible here? That is strange. The wiring has improved right here, and let me show. Yeah, in the dark you might see a flickering of LED, which is right here. Oh, you can't see anything now. Anyway, the LED where it is about is right here. And now my finger comes across, and that is more than a few seconds late. So let's measure the delay. Pointing at the LED. 1, 2, 3, 4, 5. Yeah, pointing at the LED. So that is very strange. Unusable actually. But concentrating here, it doesn't work. Alright, once more some reasoning without changing any of the code. Here I see per millisecond a very frequent signal. In fact, yeah, as frequent as this is. So per 1/8 of a second. Why don't I see that here? This is set to 5 microseconds. And so this is in fact 1.2 million microseconds. So I should see here a very frequent signal, but I don't. There's once in a while a very nice signal, but not here. If this value is as frequent, then I should see here something of a signal like this, or something like this. So some waveform anyway, sawtooth, sinusoid, whatever. But I don't. Just one constant signal. So this is now 5 microseconds. Let me change it to, let's say, 1 millisecond. This. And of course it just ended, so I start again. Now this kind of shows the same as this one, but where's the difference here? And yes, on the LED shows the constant signal, the constant glow that this is. But if I interrupt, I expect it to disappear, which it doesn't. Am I wrong in wiring? No, because I've checked it multiple times with the datasheet. This is correct, or the datasheet should be wrong, and I doubt that. So then, with all that reasoning, can I do more? Can I go to 500? Let's do that. Which is 0xff by the way, and which should give a very different thing. So what does FFF go? Let's see. What does this mean? So this is time sleep, and let's add another one. Right. See what that means, if anything. Ah, that is not accepted. Must be in range. Yeah, to be expected. So FF is maximum value. Can I change that somehow? I don't think so actually. Can I change it in another way? So this one can just as well go again. But the signal stays where it is at, if I'm quite clear, at 2.5 volts, because this one block is 5 volts right now, so it's half, which means it is 2.5. Not even, or maybe 3, maybe 3. Anyway, this is not what I expect. So, what to do about this signal? Yeah, checking the data again. Alright, I've done some searching, and unfortunately one of the sites that I used for info has disappeared, but another piece of info used this number for baud rate, which is the number of data per second, and well, that is double what I used, including the fact that they don't use this. Haven't tried yet. Also, the datasheet tells me that 16 bits are being used, and 16 bits is 2 bytes, and I'm using 1 byte. Well, the first byte is supposed to be the channel that you're using, So if I go here, then they use by to select which converter they're using, A or B. I'm using A. So since the information on the protocol which I use, Pi GPIO, is rather scarce, I will have to try this one. And it says it takes exactly 3 arguments. List 3, which then is which one? Oh, where? Line 41. This one. No, 41. Alright, where? So in what way is this suddenly wrong? Oh, yeah, of course. Okay. Yeah, I've been trying to use different signals in the first digit, the first argument. Didn't make any didn't do anything different. No message, no error messages there. So let me change that and go again. And I found yet another place where somebody complained that it didn't work, so I'm not alone in there. The only point is that also there was no answer given to his problems, assuming it's him posting the error. So the fact that I have signal here, I get the signal here as well, means that it does work, but why no signal here? The LED is burning faintly, very faintly, and I would expect that with maximum value here it will burn very brightly, but apparently that doesn't happen. Also, when I stop it, even then it burns. So there is something quite weird. Also, the use of this, as far as I can find on the net, is very scarce. It is also being used in C, not in Python, at least as far as I can find. And the software that and like I said, the site that I could find with use in Python has gone. Well, the site is not gone, but the information is gone, which basically means the same. So where to go? I'm afraid I don't have an answer as yet. I've tried a couple of things now, and knowing that the SPI works with this one, the 3-wire hasn't proven itself yet. With a constant value here, and yes, I can change it to the second output, but I don't know whether or not that is good use. So let me change that to, and yeah, I have to be quite careful with this. So changing this to here. Now there is no there's nothing on the LED. And also here there is nothing. So let me run it again. Will this do anything at all? Answer is nothing. Absolutely nothing. So this shows actually that it really is addressing. No, there's nothing. And when I now change this back to this one, it is clearly addressed. So it is output A, that is for sure. Yeah, I can put this somewhat on top. But that's all there is. And now this one has dropped for some reason. Now it's gone. There it is again. So sometimes 0, sometimes, and I don't know why. It is chip select, yes. So riddles all over. That doesn't do anything either, unless with delay, but no signal. Nope, go on. And here it goes again down. So there is apparently a delay. Let's count. Stop. But this is channel for the clock, this is for the data, and this is for chip select. Okay, select or whatever. Okay, go. Nothing. And this stays up. Weird. So I will leave it at that for now. Testing doesn't reveal anything except for the CS channel that goes down, and for us nothing. I don't know where to get more information, so if I get, then I'll go on. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, much appreciated if you know more about it. You can also follow me via Instagram and Twitter. Please donate if you like this video and my channel and wish to support. Much appreciated. You can donate via PayPal and Wired. PayPal for international and Wired for Europe. And you can also choose to become a patron and have your name mentioned. Works also via PayPal. More information. Your name will be mentioned on my website, and depending on the pledge you make, also with my videos. More information on my website, which is mentioned under this video. And well, this is going to be continued. Have a nice day, and bye bye.